Hello, can you hear me?
Yeah,
How are you guys doing? Okay, I've been seeing. All right. Today I'm gonna introduce something new, a new topic, and a new chapter. Okay. So this one we continue from there next week. Um, these are the topics I'll be doing for the next week, 2 weeks. Data description. Okay. So we're doing it every this week, next week, and the following week, we'll be working on data description. Uh, so as you already know, in statistics, what we do is to collect data, present it using the graph and charts, and then analyze it. So under data description, we'll be looking at this concept, these topics, measures of central tendency, measures of variation, measures of position, and at the end, we will look at the exploratory data analysis. So let us begin. Start with the measure of central tendency. The measures of central tendency describe the center point of a data set or distribution. So usually most common measures we use for central tendency are the mean, the median, mode, and mid-range. Usually when you tell somebody that you are teaching statistics or that you are doing statistics, most people automatically conclude that you are working on mean, median, mode. But actually those are just the beginning part of statistics. So the means tell us the average of the distribution. The median is the middle value of the distribution. For example, when we say that the median income of a college professor is $65,000 per year, that means that half of them make 65,000 a year or more, and the other half makes $65,000 a year or less. Now, for mean, which is average, you can say the average gas prices, average income, average age of students in Baltimore City public schools, can be anything. Now, mode is uh, the mode of a data set means the data value that occurred most often. So normally we use mode as, the data value that have the highest frequency. So the mode is used as a measure of popularity that reflect central tendency. For example, we can say that the most preferred stock in the stock market, that's the mode, the modal stock, the most preferred washing machine, the most popular presidential candidate. All these are the one that show the one that receive more votes. That makes that person the mode. Okay. Um, so now other things we need to know about the mode is that if a distribution or a data set has only one mode, we say that data set is unimodal. If it has two modes, bimodal. If you had more than two modes, multimodal. Okay. Next thing is the mid-range. Mid-range simply means a rough estimate of the middle value. So a rough estimate of the median. Normally we calculate it using this formula here for the mid-range. Minimum value plus maximum value divided by 2. Now all these things that I mentioned, mean, median, mode, mid-range, you can see that they have their formulas. We use this symbol here for population mean. We use X bar for sample mean. And the mean of the sample is this symbol like look like an E is a Greek word, Greek letter for sum of. sum of x over n. X bar equals sum of x over n. That's what we use to calculate the mean. Median for ungroup data is just the middle value of that data set is the median. And the mode is what that have the highest frequency. Let us look at a measure of variation. I want to introduce them. Now I have introduced you to measure of central tendency. Let me introduce you to measures of variation. No, so things varies. Okay, for example, the speed limit in a particular road might be 40 miles an hour. So you can see some people going 45 miles, some going 35 miles. Okay, if you're going 35 miles or 45 miles, I mean, in a 40-mile road, nobody will bother you because the variation is small. But on a 40-mile per hour road that you're going 60, of course, if the cop sees you, they'll stop you because the variation is high. So things vary. That is what measure of variation help us to assess. So the measures of variation describe how an individual data value have strayed from the mean or from the center. So the measures we use for the variation include the range, variance, standard deviation, and the coefficient of variation. Range simply means, range is the easiest to calculate. The maximum value minus the minimum value give you the range. So maximum data entry minus the minimum data entry give you the range. Variance have a formula we use for that. And then the standard deviation also has a formula. As a matter of fact, you get the variance first before you get the standard deviation. So the standard deviation is one that most time we use. Yeah. Because the variance will square the deviations and give you a very big number that is not, does not really mirror what you are looking for in the data set. But the standard deviation will give you the square root of the variance, and then that one is more reliable. Okay. Now let us look at the formulas. The population variance, we use this symbol beta squared. For the sample variance, we use this symbol s squared. And this is the formula for sample variance. Sum of x squared minus sum of x squared over n divided by n minus 1. And the sample standard deviation is simply means the square root of the variance. That's how you get sample standard deviation. In fact, the standard deviation is the square root of variance. Now, some of the formulas you'll be seeing here might be looking like like monsters. But when we start using them, you'll see that they're really easy to use. For the coefficient of variation, this one is more popular, very popular among stock brokers. So if I want to check how this stock varies with the index, like S&P 500 index, and so on and so forth. Or you can use it to compare the cost of living in two different cities. We use a coefficient of variation. You can use that as well. So anyway, now let us start the computation for ungroup data. Ungroup data sets means the data set that are not placed in groups or some categories. Let's look at this first example. This first example, we're going to use it to calculate the mean, median, and mode, mid-range. So it says an experiment was conducted to measure the effectiveness of a new procedure for pruning grapes. Each of the 13 workers sampled was assigned a task of pruning an acre of grape. The productivity measured in worker hours per acre is recorded for each person. See the productivity here, 4.4 hours per acre, 4.2 hours per acre, and so on and so on. It says compute the following: the mean, the median, the mode, the mid-range, and the interpret your result. So the way to do this is to present it in a tabular form, in form of a table. Okay, so when I use a table, this is a table where I put all these numbers 4.4, 4.2, all of them, you can see them in this table right here. Each number is present an x, like x1 give you 4.4, x2 give you 4.9. So now, once you put them in this form, next thing is to find the total. If you add all these things here to give you the total of 59.3, I mean, you can double check it with your calculator. And how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 of them. So our n is 13. So let me write this down so we can now get the mean. Our n is 13 because there are 13 of them, and the total is 59.3. Okay, 59.3. With this, we can find the mean of this data set. Okay. Now I'm going to take you to, this place will not allow me to put the formula, so I'm going to take it to where it will help us to, it will, the next workbook, where we can be able to put the formula. Here is the workbook right here. I think I closed it, so I'm going to open it again. Okay. So in this workbook, we can be able to use the formula. Then after that, we can copy it to the main workbook. So let us insert the mean. Let us calculate the mean, I mean to say. So the mean equal, I'm going to make this too big, make it font size 18, so you can see it clearly. Mean equals, you're going to have, and of course, you know that the mean is represented by what we call the x bar for sample mean equals sum of x over n. Okay. Now, when you look at our data set, you will see that the sum of all the numbers is 59.3 and n is 13. So that our mean now becomes 59.3 over 13. And that will give us the mean. So we can do this. I'm going to write this down. Mean x bar equals 59.3 over 13. Now we can go to our calculator and get the answer for this. So for our mean, I open the calculator. This okay, the way it shows, okay, doesn't show everything I open on the screen. This is a calculator right here. So the mean becomes we got 59.3 divided by 13. We have 4.56 rounded. 4.56 rounded. Okay. 4.56. So we're gonna go and put this in our workbook. 4.56. Okay, 4.56. Work out. Okay. We can put right here 4.56. We got our answer. Okay. So what does this mean? It means that the average amount of time taken by workers to prune an acre of grape using the new procedure is 4.56 hours. Any question on that? Any question? Yeah?
No.
Okay, good, excellent. Now let's look at the median. For the median, we put the data set in order, in ascending order of magnitude, from the lowest to the highest. There are 13 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the middle one is the median. Number in the middle. I got This these are 6. 1, 2, 3, 4, 5, 6. Okay. And on this side, I got 6 as well. See? 1, 2, 3, 4, 5. So the median is the one in the middle, which is this one right here. Number in the middle is the median. Median is 4.5 because it is number in the middle. And what does this mean? It means that half of the workers can prune an acre of grape using the new procedure in 4.5 hours or less, while the other half can do it in 4.5 hours or more. Okay? So far we have answered question numbers part A and B. Let's look at the mode now. Okay? For the mode, again, you arrange the data set in order from smallest to largest. The one that occurs most often, we have 4.4 occurring 3 times here. And 4.8 occurring 3 times here as well. So the data set have 2 modes. So the modes are 4.4 and 4.8. Note that the data set, this one have 2 modes. Some data sets have only 1 mode. So it doesn't mean that all of them have 2 modes. No, this one have 2 modes. Others have 1 mode. Yeah. And what does this mean? It means that in that experiment, the modes are 4.4 and 4.8 work hours per acre, and they indicate that these were the most frequently occurring productivity rates among all the workers who were pruning the grape, which means that the rate are common benchmark for the task. Okay. Now we can now answer the mid-range. Mid-range simply means the minimum plus maximum divided by 2. In this case, the minimum smallest number there is 4.2. So we got 4.2. Okay. 4.2 plus maximum is 4.9 divided by 2. So I'm going to write this down. I got 4.2 mid-range. 4.2 plus 4.9 divided by 2. Give us the mid-range. So we're going to go put this in the calculator. Okay. We got 4.2 plus 4.9 divided by 2. I mean 4.55. 4.55. We'll go over there and put it in. 4.55. So you can see that you look at the median, because remember the mid-range is just a rough estimate of the median. So you look at our median. Our median was 4.5. Now mid-range is 4.55. So it's a good estimate of that median. Now, any questions so far? Any question? Any question, guys?
No.
Okay, good. Now let's look at I think we're at this point, we're ready to take a look at the at the measure of variation. Okay, measure of variation. Let's look at measure of variation at this point since I've finished measure of central tendency. But before I do that, I want to show you something. This median here, the numbers are 13 a number, that is, they are odd. It is easily, it is easy to pick up the median from that when they are odd number distribution. Sometimes you don't have a distribution, a data set that is odd. You might have a data set that looks like this one, where it's even, because how many numbers? 1, 2, 3, 4, 5, 6. Unlike this one, which is 13 a number. In that case, the median stay right in the middle for you to pick it up. Here, they're not like that. It says 1, 2, 3, 4, 5. So there's no single number at the middle. In that situation, how do you find the median? Let's do it. You say find the median of the weight listed below. So if you look at it, you arrange it in order of magnitude. I think it's already arranged. Okay. Now, in this case, there are two numbers at the middle. Let me make sure they are arranged already. 2, 2, 3, 2, 3, 5, 2, 3, 5, 2, 6, 8. Okay, it's arranged. There are two numbers in the middle. See? So in that case, median will be the average of the two numbers. 2, 3, 5 plus 2, 6, 8 divided by 2. And that will give you the median. Write this down. Median for this particular data set is 235 plus 268 divided by 2. Let's go and put it on the calculator. Okay. I got 235 plus 268 divided by 2. Give me 251.5. And that becomes our median. 251.5. I'm going to go and put it right there. 251.5. So this is give you a foundation information on measure of central tendency. Now we can proceed to measure of variation. We start with the easiest one to calculate, which is the range. Okay. It says data on European auto sales for the period of 6 years is shown here. These data are in billions of dollars. Actually, millions of dollars, not. Yeah, it's in billions of dollars. Yeah. It said, calculate the following: the range of the data set, the sample variance, and the sample standard deviation. So the range simply means the maximum data entry minus the minimum data entry. So the range will be the maximum there is the largest is 14.3, I believe. Yeah, 14.3 is the largest. Minus the minimum. I think 11.2 is not. Yeah, it should be 11.2, the smallest. Yeah. 11.2 equal. So I'm gonna write this down. Range equals 14.3 minus 11.2. Give you the range. So we go and put this on the calculator. We got 14.3 minus 11.2. Give me 3.1. 3.1. So our range is 3.1. Which means that European auto sales that are varied by a range of $3.1 billion over the 6-year period. Okay. Now, we can now answer part B and C on the view. To answer part B and C, excuse me, you have to make a table of values of this type. See, so this is part X. Represent each of these numbers here. Okay, so it's X. Now we need to get, before I do that, I want to tell you this. In statistics, there can be up to 3 different formulas for finding something like the variance. I recommend that you stick to the one we use in the class so that you don't get into trouble doing the wrong thing. Okay. So now means this formula for this we'll be using the formula for variance. I'm gonna show you in a minute. But to get the variance, we need to get this part, which is called the x squared okay, where you square all the x's. Okay, you square all the x's. Okay, I call it x squared. Okay, so where does x come from? X come from the number they given. 11.2, you can see right here. 11.2. 11.9, you can see right here. 11.9. So now you square it. 11.2 squared. I think I have give me 1 minute. Yes, I have something right here. And I made it's fast. Yep. And you can do it. Anyway, 11.2 squared means we go to our calculator and say 11.2 square it. 125.44. I'm going to put it right there. 125.44. Now, you continue like that. If you square this one, 11.9 square, you're going to get 141. Yeah, 0.61. For 12 square, give us 144.00. Then 12.8, if we square it, you're going to get 163.84. You can always verify this with your calculator. Then we have 13.4. If you square it, you have 179 point 58. So 179.56. Then we have 14.3. If you square it, that means 14.3 times 14.3 give us 204.94. 0.49, sorry, my mistake. So let's see, this is the result. So now we're going to add all this to get the total. So let me take you to calculator so we can add all them to get the total. So we got this as we have 125.4, 125. Oh, excuse me. 125.44 plus 141.61 plus 144 plus 163.84 plus 179.56. Okay, 0.56 plus, okay, that's 79.56. Then last one is the 204. 204.09. Give me 958.94. I can see right there, right there. 958.94. See, 98%. So we're gonna have 958.94. And when you add all this one here, you're gonna get 75.6. This is the symbol we use for sum of. This means sum of. And how many of them do we have? 1, 2, 3, 4, 5, 6. So n is 6. Sum of x squared. This is x squared right here. And sum is 958.94. You can see right here. And x is right here. The sum is 75.6, which is this is sum of x. 75.6. So with this, we are ready to calculate the variance and the standard deviation. Yeah. So let me write them down first of all, and we can go and get our variance and standard deviation. We got that n. Okay. N is 6 of them. And then we have our sum of x as okay, sum of x as 76 point, sorry, 75.6, and sum of x squared as right here, you can see right here, 958.94. With this, we're ready to calculate the variance. So it won't allow me to put the formula here. So I'm gonna take you to the other workbook where I can put the formula. Okay. So at that workbook, I can put the formula there. And we can get our variance. Okay. So I have, give me 1 minute, let me put this. Okay. Now, the variance should be variance equal. Okay, we're gonna have this. Okay, sum of x squared minus, okay, we got sum of, okay, sum of x squared by n. I think I'm gonna put this in a, okay, yep, I'm gonna put it in a parenthesis. Okay, then before adding parenthesis. So sum of x squared, sum of x, oh, I think I should remove this one. All right, let's say sum of x, which is this sum of x squared over n divided by n minus 1. Okay. And from this, from what we have in that workbook and from our table, you see that sum of x squared is 958.94, which is right here. And sum of x is 76.5, 75.6, which is right here. And n is 6. So we just go and plug those values inside the formula and we get our answer for variance. Sum of x squared, I don't think I wrote it down somewhere. Right? Oh, I got it. 958. 958.94 minus sum of x squared. Okay, I'm gonna make it put a division symbol there. Sum of x squared, which is okay, 75.6. Okay, squared divided by n. Our n is 6. Okay, all over 6 minus 1. That gives us our variance. So let me write this down so we can put it on the calculator. I got 958.94 minus 75.6 squared over 6. Divided by 6 minus 1. Okay. So let's put this in the calculator. I will get our answer for the variance. Going to our calculator, we have this. Okay, you got 958.94. Okay. Oh, excuse me. Got back. Minus sum of x, 75.6. squared over n, which is 6, divided by n minus 1, which is 6 minus 1. 1.276. 1.276. That would be our variance. 1.276. Okay. This is 1.276. So we're going to put it right there. 1.276. I'm going to make it probably 16. Okay, so I'm going to copy this and we're going to go and paste it in our main workbook where the answer is needed. Okay. The variance right there. See? And the standard deviation is just the square root of the variance. Okay. Variance is 1.276, or you can call it 1.28 if you like. Okay. Now let's find the standard deviation. Our variance is 1.276. So the standard deviation will be the square root of the variance. Standard deviation equals the square root of variance. Okay. Okay. Which will be square root of, because our variance, our answer for the variance was 1.276. So we have to go and put it right there. The square root of, okay, 1.276. Okay. So let's go and put this on the calculator. Okay, square root of 1.276. 1.13. That's 1.13. 1.13. Okay. It is. And then paste it into our main workbook. Now, although I don't require you to interpret the variance or standard deviation, but let's look at it. Look at the standard deviation. So you say that it is small in value, which means that 1.13, that's the deviation, standard deviation. That the variation of the European auto sales during the CCA period is not significant. And you can even see it from here. Variation is not that much. 11.2, 11.9, 12. So it doesn't vary so widely. Any question on this one? Any question, guys?
No.
So probably we might look at the equation of variation. If they didn't ask it here, but let's see if you can do it. The equation of variation. This one, basically what it does is that use to compare two things, compare it. Like you can compare the cost of living in two cities. Somebody who lives in New York City making 100,000 a year is almost the same thing as somebody who lives in Baltimore City and making only 70,000, because cost of living in New York City is more higher than that's about Baltimore. So you need to compare so many different things. Let's see how it works. It says the mean number of sales of cars over a 3-month period. As a matter of fact, let us do it. I think I have. I want to elaborate more on this. Okay, I have 2 of them. Okay. Yeah, let's do two equations of variation on Tuesday. Let's start from there because I want to solve 2 questions on that. Yeah. Any question before we leave? Any question? Hello.
Yeah, you're gonna like publish because you're recording, right?
Yes, I'm recording. I'm gonna post the video after the class.
All right, cool. Thank
But
you.
before you go, I want you to in fact, you know what? Let us do this. Let's do this one. Maybe on Monday we do the other one so that we can know that we did two. Let's do this one, just this one. Then on Monday we do this particular one. Now it says here the mean number of sales of cars over 3 months over a 3 month period is 87, and the standard deviation is 5. The mean number of commission is 5,225, and the standard deviation is $703. Compare the variation of the two. Now, this is the formula for finding the coefficient of variation. S over X bar. That means standard deviation over the mean times 100. For the first one, say the mean number of cars over a 3 month period is 87. Say X bar, which mean is 27, and the standard deviation is 5. So for this one, the coefficient of variation will now become standard deviation divided by mean times 100. And in this case, the standard deviation is 5 divided by the mean of 87 times 100. And that will give us the coefficient of variation for this one. So 5 over 87, 5 divided by 87 is times hundreds is I don't apply it right. You gotta come out from times hundreds. 5.7% or 5.75% rounded. 5.75%. Let me double check it, make sure I put the right number. 5 by 87, right? And look at the calculator. 5 by 87. Yeah, 5 by 87 times 100. I mean, 5.75%. Okay. Now, for the other one, the equation of variation, in this case, is the commission is 5,000. The average, the mean of the commission is 5,225, and the standard deviation is 773. In that case, we're gonna do gonna be 773 divided by 5,225 times 100, and that will give you the coefficient of variation. Okay, let me write it down. 773 over 5,225. Okay, you can go and put this on the calculator. You got 773 divided by 5,225 times 100. 14.79%. 14.79%. Okay. We got 14.79%. 14.79%. You can see that the commission is larger. See, for the sales is 5.75%. Commission is 14.79%. So commission is larger. So the commission varies more than sales. Okay. Now, when we come back on Monday, we'll do the I will show you how to do this one. For this one, we're gonna use Excel to do it. That'll make it faster. And then I will show you how you can use Excel to solve what you just did before I introduce you to grouped data sets. Okay. So now, let us do let me check your name and attendance, and then we can now leave. Any question again before we leave? Any question? Don't go yet. I want to take down your names, attendance. Don't go. I'm looking at it now. Okay. I got when here. Okay, I got Max Alexandra. Okay, I got it. Bets. I got bets. Richard. Okay. Yeah, that. Heston. How come I don't see Heston? Okay. Got it right here. You got Wise. I got Wise already. And Holland. Got it. I got a Mentor. Yeah, I got Mentor right here. Okay. You there. Micah. Got Micah. Micah, you there. Okay. I got Lily. Okay. Patrick. Yeah. Sarah. Sarah, what's your last name? Sarah. Sarah.
It's Durant.
Huh?
Sarah Durant. Durant.
Oh, I see it now. Okay. So, I mean, if I have got Coles, you guys had their name. So if you had a name, you are free to leave. Okay. Coles, Kia, Coles. Yeah, I got the Coles. I see you guys on Tuesday. You have a nice weekend. Hmm.